Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This is hopefully a short tutorial video about couple moments in 3D structures. Now, this should be easy conceptually, but I find that many students ask about this, and apparently, if you have never been tested about this, you might get some problem with this, right? So hopefully this will help. Inshallah, let's make it short. Now, in 3D structures, basically, if you look at these two diagrams, it is basically from a 3D structure in real life. However, when you look perpendicular to the plane of action, it becomes 2D problem, right? In these two problems, right? So if you imagine x-axis like this and y-axis like this, right? It will mean that z-axis is going out of the screen towards you, right? The z-axis will be going out of the screen towards you. Now, in terms of scalar, right? So if we want to calculate this, it's straightforward. M equal to F times D. So in this case, it will be just 30 Newton times 0.4 meter. Then you get something in terms of Newton meter. But what if you need to find this in vector, right? So how to convert this into vector form? So basically, you just multiply by the unit vector of the axis of rotation, right? So in this case, the rotation is clockwise like this. So if you understand your right hand rule, if you put your four fingers in this rotation, you will see that your thumb is going into the screen, right? Your thumb is going into the screen. What that means is the unit vector will be minus k, right? Because z-axis positive is going out of the screen towards you. So when your thumb is going into the screen, it is a negative k direction, right? Negative k direction. So moment vector is just moment times unit vector there, right? So whatever value there, you times by my negative k, and then you will get the vector, right? Similarly with this one, because the rotation is in this way, your thumb is going into the screen, so unit vector is the same, right? So that is the simplest form. Hopefully you understand. So let's go into this one, right? So if you understand that, so you should be able to understand this as well, right? So when you get a magnitude of moment, right, it rotating like this, and meaning that your thumb is going here. So the only thing that you need to do is you need to find what is the unit vector in this direction, right? So vector moment is just the magnitude times the unit vector, right? Similarly here, if your rotation, this is your four fingers, right, rotating like this, and then your thumb is going here, so what you need is just this unit vector here, right? So the, sorry, my number is wrong, so this should be one. Sorry, this is should be two, right? This should be one. Okay, so moment one here is just unit m1 u1, right? Hopefully, yeah, hopefully all this catch. So the concept is straightforward, so let's move forward. What about this one? Okay, so in this case, if you look from a perpendicular to the plane of this couple moment, right? So it will just look something like this, right? With 150 Newton, 150 Newton, and the perpendicular distance will be just 0.4 meter, right? So when you want to calculate moment using scalar, so this is just 150 Newton times 0.4 meter. You will get something in Newton meter, right? But what about the rotation? What if we want to find in terms of vector, right? So you can see this is rotating about this axis, right? It is parallel to x-axis, and the rotation itself is rotating like this, correct? It rotating like that. So if you put your right hand rule here, you put your right hand, your four fingers are rotating like this, your thumb will be in that direction. So in that case, you will see that unit vector will be positive I, right? Because it is in the positive x-axis. What about this one? So in terms of the magnitude, right, it is basically just F times D, right? So hopefully you can imagine as such as this one, right? If you look perpendicular in here, basically it's just something like that, right? So 125 Newton and then 0.3 meter. You know what to do. M equal to F times D. What about the rotation? The rotation, of course, it is about this axis. And if you look at the rotation there, based on this rotation, right? So you will see that the rotation is, your thumb is going in this direction, right? So as long as you can find this unit vector, this will be fine. And in that case, you should note that this line here is on the YZ plane, right? In YZ plane. So if I redraw Y and Z, the line is something like this. So can you find the unit vector? Right, of course, this triangle is what? Is 3, 4, 5. So in terms of you finding the unit vector, you just imagine, because we understand the concept, right? Unit vector, if you get the magnitude, it is 1. So it is basically, if you draw the magnitude, it's just basically just 1. So what is this component and what is that component? Basically what it is, right? So if you want to find this component, it's just basically 3 over 5. If you multiply by 1, it's basically 3 over 5 yet again, right? So similarly here, it will be 4 over 5. So we know that y-axis is 3 over 5, z-axis is 4 over 5. So the unit vector will be 0i plus 3 over 5j plus 4 over 5k. Right, so that is the unit vector. So once you get this unit vector, you multiply by the the magnitude of moment here, right? When you use m equal to f times d here, multiply by the unit vector, you will get the moment in Cartesian vector form, right? So as you know, m equal to m times u, right? So yeah, okay, moving on. What about this one? So the concept is again the same, right? So I'm going to repeat the concept again and again. It's just that this is just a practice to see whether you can identify the unit vector for each case. In this case, okay, in this case, your rotation and your thumb is already shown, right? So your thumb is already going there. So the unit vector should be straightforward here, right? Unit vector will be what? Minus k, right? It is negative z-axis direction, right? So minus k. In this case, unit vector, it will be in this direction, right? Correct. So it is in the x, y plane, but x is positive. Y here is negative, right? Because y positive is here. So this is y negative. Right. So what will be the unit vector? So we have to use this triangle or this ratio, right? So if I'm looking from top, the triangle will be looking like this: 1.5, 2, 2.5. Right, this is, I'm using this triangle. Or if you want to use this triangle, oh, why is it becoming the same? It become, yeah, it will become something like this: 1.5, 2, or 2.5, or it's just same ratio as 3, 4, 5, right? So based on that, you can determine if we want to find the unit vector, right? So unit vector, you just make the magnitude as 1. So in this case, when you find the component, so you'll have x component positive, so positive 3 over 5 I. Y component is negative, so negative 4 over 5 j, and then plus 0 k, right? So this is if I'm using 3, 4, 5. If you use 1.5 to 2.5, you'll get here 1.5 over 2.5. Here you get 2 over 2.5. Okay, doesn't matter. What about this one? This one way that you can do, if you just make this a coordinate, for example. So what is this? Negative 2, 2, 3.5. So if this is the coordinate, and this is of course 0, 0, 0. So from here you can get what is the position vector, the magnitude of r, and then unit vector, right? So you can get that one. So that's how you can get unit vector using different method. This one is straightforward. This one you can just use the triangle and notice that it is you can use this triangle straight away. This one you can actually use the coordinate and position vector, right? So all of this is just to get the unit vector of the axis of rotation. Next. All right, what about this one? So again, the concept is the same. So m equal to f times d. This is scalar calculation, right? Of course, when you want to calculate, make sure you avoid mistake. For example, this one, what is given is the radius, right? So make sure if you tend to make mistake, just write it clearly. The distance is the diameter should be 175 times 2, which is 350 millimeter, right? So that when you want to calculate, so you have 335 Newton, for example, and then if you want to use meter, 0.350 meter, right? And then you get something in terms of Newton meter. So what if you want to, if you need, of course, in this case, normally you need to convert into vector. So in this case, the axis of rotation is clear, right? This is the axis of rotation, is the x-axis. However, you should note the rotation, right? So the rotation will be like this, right? If you put like that, your fingers is like this, then your axis, your thumb will point this way, right? If your thumb is this way, then it is negative I, right? Because it is pointing to the negative direction of x-axis. All right, what about this one? So in terms of F times D, it is also straightforward, right? So M equal to F times D here is just 25 Newton times same the diameter, right? 0.350 meter, right? So you get something in terms of Newton meter. And the axis of rotation is this one, right? And then this one will rotate like this. If this is rotate like this, your thumb is pointing there, right? Hopefully you can notice that if it's pointing in that direction, it is actually x in the negative and y also in the negative direction. Correct? So if you redraw this in, let's say, in xy, this is an xy plane, right? So if I look from top, it will look something like this, right? This is x-axis, this is y-axis. So it is something here, correct, with 60 degrees, right? This line here is this line if you look from top, right? So if you want to find the unit vector, of course, you just make a vector of magnitude 1. Okay, in this case, because it's the direction is that way, so I'll draw it like this to avoid confusion, meaning that x is negative, y also is negative. So if the magnitude is 1, can you determine these two components? Sure, you can, right? So in this case, it will be 1 cos 60 degrees. In this case, 1 sine 60 degrees, right? I explained earlier, right, what is this one, because the magnitude of unit vector is always 1, right? So in this case, the unit vector is what? X component is negative, so negative 1 cos 60 degrees I, and then y is also negative, negative 1 sine 60 degrees j, and then plus 0 k, right? So you get the unit vector there. So when you have already get the magnitude of moment, so vector of moment is simply just magnitude times the unit vector. So you just multiply by this, you will get in terms of vector form. Obviously, you will have x component and y component and no z component, right? So that is for this one. So let's move on to the next example. All right, what about this one? This one is also not difficult, should be, right? Because if you look, okay, there's 4 set of moment here, 1, 2, 3, 4, 4 set of couple basically, right? So in this case, it is rotating about this axis, right? So if you consider that, the rotation is in this way, right? If you rotate about that way, so if you rotate your fingers in that direction, you'll notice your thumb is pointing down. So in that case, unit vector is minus k, correct? What about this one? It rotate about this. Okay, I do not focus on the magnitude because it's just m equal to f times d, right? So in this case, f times 0.2. In this case, f2 times 0.2, etc., etc., right? So I'm not focusing on that. I'm just focusing on the unit vector. In this case, the rotation will be like this, correct? And then you'll notice that if you put your right hand there, your thumb will be in this direction. So in this case, u is positive I, correct? What about this one? Axis of rotation here, the rotation will be like that, meaning that your thumb will be in this direction. So unit vector will be minus j, right? Because it is parallel to y and it is negative direction. What about this one? Okay, there's two things here. So I'll just mark this as a green, right? So this green couple, right? So if you draw the forces, if you look from one angle here, so it will be something like this, right? Something like this with the distance given like that, right? 0.3 here. So if you want to calculate using m equal to f times d, what you need is a perpendicular distance. So this is not the perpendicular distance. Perpendicular distance we have, okay, so first you can prolong the force. So you make this force longer, you make this force longer, so that the perpendicular distance will be obvious there, right? So this is perpendicular set. So given that this already give the angle as 30 degrees, so d here is just 0.3 times cos 30 degrees, right? Which is this d, right? So m equal to f times d. I think you should know what to do now. 150 Newton multiplied by this distance, you get the magnitude. Correct. So, but again, what is the rotation axis of rotation? It is this, the axis of rotation, and the rotation will be like that. So, if this is the case, your thumb will be in this case. This case is parallel to x, positive, right? So, unit vector here is positive I. Correct. So as you can see, calculation using scalar is straightforward. It's just f times perpendicular distance, and then the unit vector you just focus on what is the axis of rotation, and then you just see how the rotation is and identify where your thumb is pointing at. All right. So done with this. Let's go for the next question if there's any. All right. So same here. Oops. In this case, unit vector should be obvious, right? In this case, unit vector is positive k, right? So meaning that if you want to use find the vector for this one, is straightforward. Straightway is just 300 k positive. In this case, 100 k, right? In this case, Newton meter. In this case, Newton, right? What about this one? So the unit vector obviously this way. So if you redraw the axis, if you redraw the axis, if you look from top, right? So it will look like this, x and oh sorry, x and okay. Let me redraw. If you look from this, okay. If you look from this, it will be something like this. X is here, Z is here, right? And it is like this, right? And then you have 45 degrees. So the unit vector is like this, right? So if the magnitude is 1, so you would know what is the x component and z component, right? So the x component, so in terms of the unit vector, the x component will be positive 1 cos 45 degrees I, and then y component is 0 plus 0 y, plus 0 j, and then z component is negative, so negative 1 sine 45 degrees k. Right. Sorry for the messy writing, but I'm rushing here, so that's why. So that is the unit vector. So for if you want to find the vector, so this just magnitude times the unit vector, right? Magnitude times the unit vector. I think that should be clear, right? Is there any other example? Okay, so that is it for this short tutorial. Hopefully it helps, and yep, hopefully it helps in your understanding as well as answering your question. So thank you. Wassalamualaikum warahmatullahi wabarakatuh.